A heating duct is capable of replenishing the air in a room of volume 300 cubic meters every 10 minutes. So in part A, what is the volume flow rate of the air in the heating duct? So volume flow rate, capital Q, is equal to volume over time. The volume is given as 300 cubic meters divided by a time, which needs to be in seconds. So we're going to take that 10 minutes and convert it into seconds by multiplying by 60. So you have 300 divided by 600, which gives you an answer of 0.5 meters cubed per second. For part B, if the heating duct is circular with a radius of 15 centimeters, what is the speed of the air in the duct? So taking the other equation for volume flow rate and rearranging for this time a lowercase v for speed, it is Q divided by the cross-sectional area. So Q, what we just figured out in part A, divided by, and since it's circular and the radius is given, we'll replace the A with a pi r squared. And now plugging in the numbers, the Q from part A was 0.5 divided by pi times the radius, 15 centimeters, converted into meters, that's 0.15 squared, which gives you a speed of 7.1 meters per second. And for part C, what would be the airspeed if the duct had twice the radius? So just basing it on the equation we did in part B, the speed is equal to Q over pi r squared. You can see that with twice the radius, since the radius is squared, that will get doubled and it's in the denominator. So 2 squared is 4, and being in the denominator, that would reduce the speed by a factor of 1/4. So to write all that down, we can say that when the r is doubled, that means that the area is going to be quadrupled, and that means the speed is going to be 1/4 its original value. So in this case, we can take the 7.1 meters per second, divide by 4, and that gives you an answer of roughly 1.8 meters per second.